A vintage model traction engine restoration. This is part 8, refitting the old piping and making some new. The first thing to do is to have a look at the fittings and figure out what the thread forms are. This one, for instance, on the water bypass valve is 5/16 by 32 at both ends. But this is not always the case with fittings on old steam engines. Many times I've seen one end threaded 5/16 32, the other end threaded 5/16 by 40, or 5/16 by 26. And there's some more good news. Because the check valve is a commercial item, the union nut on the battered piece of pipe at the other end is also 5/16 by 32 threads per inch. Most of these pipe unions are coned, but the ones at the injector end are flat. I've temporarily run out of 3/16 flat unions, but I found some brand new ones in my box of old injectors. These are a pair that I took off my 7 1/4 inch gauge Titch locomotive that I used to run around my garden at the other place. So why are they flat, do you think? It's much easier having a flat connection if you want to remove the injector quickly, because you don't have to bend any of the piping to get the cone parts out of the injector ends because they're flat. It's not too bad bending the piping on this size, but it's not so good if the piping is 3/8 of an inch in diameter, like it is on my large Showman's engine. Let the pipe bending commence. This piece of pipe is going to be the one that goes from the injector steam valve on the turret down to the injector. What was wrong with the original? Well, the end of it was broken and it was badly bent. The problem here is the taps are designed for 5/32 pipe, and this was a previous attempt at joining 3/16 pipe to 5/32 pipe for a union that fits a 1/4 by 40 nut. I'm not going to extend the pipe. I don't like to see that. I'm going to extend the tap. Bending this piece of pipe was quite difficult. It bends all over the place. I thought I'd have a break from that and fit the water tank. Now you see it and now you don't. The reason for removing it is I want to look at the orientation of the fittings. This is the bush in the left-hand side of the tank where a fitting will go, and it's very important that it seals. I'm going to use some Loctite 542, but I'm also going to use a suitable shim washer to make the part a tight fit in the bush. This wasn't the first attempt. I did do this once or twice, or 3 or 4 times to be exact, before I found the right thickness of shim washers, and in the end I got away with just one. Here I am applying some Loctite 542 to the thread, and after that, not forgetting to put the water tank in the bunker first, I screwed the fitting tightly into place. This fitting, by the way, is the injector water valve tap. This fitting that goes at the other side is nothing to do with the injector. It's the crankshaft-driven pump water bypass valve. When the engine is running and the plug cock is in the open position, then all the water taken from the tank is allowed straight back into the tank. But if you close this valve, or even partially close this valve, then water is pumped into the boiler at different rates. It's a bit of a balancing act. I don't think I like the look of this piece of pipe that goes from the valve to the check valve on the back head. This clip shows the outlet pipe from the water pump connected to the T-piece, and I'm going to make a new piece of pipe to go to the check valve, which, by the way, I found was very loosely fitted into the boiler. When I renovate steam engines, I always try and do the job to my standard, just as if it was my own engine I was working on. So I fitted a shim washer to make sure it locked into the correct position, and the Loctite 542 sealant that I applied will make sure that the fitting never leaks. I've just cut a piece of 3/16 copper pipe on my bandsaw, and here I bent it into position to fit between the water valve and the check valve. I know this is a sympathetic restoration, but there are limits. After silver soldering on a pair of coned unions at each end, I fit the pipe between the check valve and the water valve, and I think it looks a lot better than the old beaten up one. Looking at the other side of the engine, it's time to work on the injector, and this is one of the original pieces of piping, and it's quite good, so I'm not going to replace this. I will only replace parts if they're badly made or broken. Bending copper pipe runs for model steam engines is much more of an art than a science. You will make a lot of mistakes. It's possibly a good idea to use a substitute, for instance bend some gardening wire to shape. Yesterday I bought a GoPro Max camera from my neighbour, and I bought it to fix on my traction engine so that when I'm running it on the road you'll be able to see where I'm going, which is more than I can. I thought I would hold it in my hand and take this clip of me drilling a union nut in the lathe because the hole in it was too small, and as you can see, the image quality is pretty good. But now it's back onto my Sony AX53 camera for the rest of the job as usual. Because it's almost impossible to do this job in a reasonable time and operate the camera professionally, I do rely on some of the automatic settings, and that works most of the time. Making a new video for my Patreon supporters every day really does take some doing, so I need as much help from the camera's automatics as possible. Now I've bent this piece of pipe to the shape that I want it to be, all I need to do is cut it off where it meets the injector, and after silver soldering a flat union on one end, I tried it for size, and I think this looks fine. The original piece of pipe that went from the injector to the check valve on the boiler was a bit of a mess, and I made a new one. That's why I was drilling out the union nut on the lathe to accept a coned union fitted to a piece of 3/16 of an inch diameter pipe, because the original was 5/32, and once again at the injector end it's a flat union. I thought it would be a good idea to flash back to the original piping arrangement. I'm sorry, but I couldn't live with this. It's best to keep the bends to a minimum from the output of the injector. I'm going to silver solder a 5/16 by 32 threads per inch coned union at this end. I marked the pipe using a felt tip pen and cut it on the mark, well, more or less. Then in the outer part of the workshop on my brazing hearth, I silver soldered the union cone in place. I haven't shown any silver soldering in this episode. If you don't know how to silver solder components, please watch my video called How to Silver Solder for Beginners. All I need to do now is machine and thread an adapter to fit between the valve and the union cone. I think this is a much better way to do it than putting a joint in the pipe. I think I'll make this adapter about 5/8 of an inch long, or 1.5 centimeters. Ever since I saw that terrible film called The Human Centipede, I don't usually refer to measurements in centimeters because somehow it reminds me of the film, so I think I'll make it 5/8 of an inch long. I'll make that in the next episode, and for now I'd like to say stay safe and well, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists, and by doing that you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.